So now we come to part 4, and we have been talking about redox reaction, and redox reaction is the reaction taking place in battery involving oxidizing agent and reducing agent. And reducing agent will undergo oxidation. That means it will be oxidized by another chemical. And oxidizing agent will undergo reduction because it will be reduced by the reducing agent. So I will remember it like this. We say that iron, the rusting of iron, that means it's the oxidizing of iron, and iron will be oxidized by oxygen and water in air. And then in this process because it's the iron is oxidized by oxygen and water, so it is oxygen and water will be the oxidizing agent and iron will be the reducing agent, and this process is oxidation. And we can see that in the oxidation, the reducing agent, this is the reducing agent, the reducing agent will lose its electron and its oxidation number will increase. So here, common oxidizing agent. In this part, in part 4, we are going to learn some common oxidizing agent and reducing agent. Because we say common, what does common means? Common means it's very common in the exam. That means you have to memorize them and you have to remember what will be formed and what it will change to. And you have to remember all these common oxidizing agent, what common oxidizing agent and what common reducing agent we have. So for the following reagents, you have to remember them. Once you see it, you know that this is oxidizing agent. And another page, okay, this page, they are reducing agent. Once you see it, then you should know that they are reducing agent. So common oxidizing agent in the laboratory. From this case, because this is oxidation and this is the reaction. This is the reaction for reducing agent. So it should be the opposite. This case is losing electron. So for oxidizing agent, it should be gaining electron. Oxidizing agent will gain electron and the oxidation number, this one from 0 to +2, it increased. So for this case should be the opposite. It should be decrease. So on another page, this one should be loses electron and the oxidation number, as that one in iron, it's increased from 0 to +2. So here increases, okay. So we know that for oxidizing agent, all of them will gain electron. That means the electrons will be always on the will always on the left hand side of the half ionic equation. Will always be at the left hand side of the half ionic equation. For example, this one, the electron should be on the left hand side. That means later, if you need to write a half ionic equation, and half equation to represent the half reaction taking place for oxidizing agent, the half reaction for oxidizing agent, the electron should be on the left hand side of this half ionic equation. Before telling you how to do the half ionic equation. Instead, I want to tell you what these oxidizing agents are. So the first one, acidified potassium permanganate. The first one, acidified potassium permanganate. It's purple in color and it's very oxidizing. So if you have accidentally poured these oxidizing agent on your 1 to 10, all these oxidizing agent on your hands will be like burned because your skin will be oxidized. And the second one will be acidified potassium dichromate, and the active ion is not potassium. Instead, it's dichromate. The active ion is dichromate. And here, the active oxidizing ion, it will be permanganate. So if you change potassium to sodium permanganate, it is still the oxidizing agent. So you can change the cation to anything because the active part of this oxidizing agent will be permanganate. And the third one will be is concentrated nitric acid. And the fourth one is dilute nitric acid. And the fifth one is concentrated sulfuric acid. These three are similar. All of them are acids. And these three acids, we didn't talk about it in Form 4. Like when magnesium react with this acid, react with hydrochloric acid, it will give out hydrogen gas, right? This is what we have learned in Form 4. Unlike these three, you can see that when they react with metal, they will not give hydrogen. Instead, this one will give NO2, and this one will give nitrogen monoxide, and this one will give sulfur dioxide. Okay, and then for number 6, chlorine gas. That's why people will also use it to make a chemical bomb. Okay, and then it will be reduced. Chlorine gas can oxidize others, can oxidize the reducing agent. At the same time, it will be reduced to chloride ion, as you can see here. For bromine, which is in the same group as chlorine, that's why they have similar chemical property, and then it will be reduced to bromide. And what is the change for it? Do you still remember what is the color for? Do you still remember what is the color for bromine aqueous solution? The color for bromine solution is yellowish brown. So when bromine oxidizes others, it will be reduced to bromide ion. So you will see the observable change will be it changes from yellowish brown to colorless. And the next one, iodine, also similar because group 6 to group 8, all of them are halogens in group 7 of our periodic table. So they have similar chemical properties. And chlorine will be the most reactive because it's do you still remember for non-metal the reactivity decrease down the group. So this one will be the first, and this one first, and this one will be the second, and this one will be for the third reactive. For the color of iodine, it's deeper in color. Its color will be brown. So when it undergo redox reaction, and when it is reduced to iodide, we will see the color change from brown to colorless. And the ninth one is iron 3 ion. I hope that you still remember the color of iron 2 and iron 3 ion. They are yellow, and this one is pale green. So when iron 3 is reduced, then you will see the observable change as yellow to pale green. And the last one is all metal ion. These ion are because these metal ion will easily get electron and then change back to the metal. So they are also the common oxidizing agent. That's why for silver ion, don't look down on it. I have tried to have some spill of this silver nitrate solution on my hands, and then there are some black spots on my skin for over 2 weeks because it oxidizes my skin, and my hands are like burned. That's why my skin have some black spot on it, but it's not very severely burned, so that's why I'm still here. So don't worry. But it's not something safe. It's an oxidizing agent, okay? So you should handle it with care. And then, so now I will tell you how to do the ionic equation. So remember, when we write the half ionic equation for the reaction taking place for oxidizing agent, the electron should be always on the right, and then there are 3 standard steps. Okay, so for this column you have to memorize it. That means, for example, permanganate will change to manganese ion. So when we do the half ionic equation, you do not need to blindly memorize the half ionic equation because you can do it by yourself, but you need to remember what it is changed to. For example, this one, okay, I know, as I remember, sorry, let me change the pen. For the example, this one, as I remember, permanganate ion will change to Mn2 plus. So the first step, sorry, it should be 4 standard steps, okay? 4 standard steps. The first one, you check the element. Here on the left, only 1 Mn, and then on the right, also 1 Mn. So the first step, you can skip it. You don't need to add. You don't need to balance the number of the atoms of this special element. And then the second step, you have to add water to balance the number of oxygen. You have to balance the number of oxygen by adding water. So how many oxygen are there on the left? There are 4 oxygen, right? And then how many oxygen are there on the right? There's 0, right? So I need to add 4 water to balance the number of oxygen. Now on both sides there are 4 oxygen. And then the third step, I need to balance the number of hydrogen. Can you see that I added 4 water? So I need to add hydrogen ion to balance the number of hydrogen. How many hydrogen are there on the right? There are 8, so I need to add 8 hydrogens. And the last steps, it's the most important one because it's half ionic equation. Because it's the half ionic equation. Do you still remember I said that before? If it's half equation, then there must be electron. So the last step, you have to add electron. How many electron do you need to add? Okay, the charge for the right hand side, because the charge for the water is 0, so the charge for the right hand side is +2, and the charge for the left hand side up to now is 8 plus minus 1, so it's +7. 8 plus minus 1, 8 plus here minus -1, so the charge will be +7. So here on the left it's +7, on the right is +2. So which side to add electron? Electron is always negative, so you can only lower it, right? When you add electron, the charge will always be lower. So now which part should be lower until they are the same? It should be the right hand side, right? -7. So +7. So +7 minus what number, then it will equals to positive 2. So the answer should be 5, right? So we add 5 electron. At last, 4 steps are done. And then now you have to check the charge. If the charge on the right hand side is equal to the charge on the left hand side. So we try the left hand side first. 5 negative and then plus 8. So the charge on the left hand side now is negative 5 plus 8 minus 1. It's positive 2. And on the right hand side is also positive 2. So now they are the same. So I know that I did it correctly. And then I will do one more for you as example. Then it's your turn to balance the others. Okay, I will do the fourth one for you as example. Alright, the fourth one is dilute nitric acid. You have to remember that dilute nitric acid will be reduced to nitrogen monoxide. So in nitric acid, the nitrate ion will react. Sometimes we will also write HNO3, and the product will be NO. Okay, the first step, balance the number of the element being reduced. Nitrogen here, only one nitrogen, and on the right also only one nitrogen. So step 1 we can skip it. And then step 2, we balance the number of oxygen by adding water. Okay, then now there are 3 oxygen on the left and then only 1 on the right. So we need to add So we need to add 2 water. And after adding water, we need to add hydrogen ion to balance the number of hydrogen. So here, 4 hydrogen ion. And at last, we need to add charge, right? The charge for the right hand side is 0. Because no charge for nitrogen monoxide and no charge for water. So 0. And then the left hand side, 4 plus minus 1. So it equals to plus 3. So how plus 3 minus what? It will be 0. So the answer should be adding 3 electron. Okay. Then it's done. This one is done. Okay. I will do one more for you as example, which is easier. For example, Cu2 plus. Change to Cu. First of all, on both sides, there's only 1 copper. Do we need to balance the number of the element? No need. And then the second step, we balance the number of oxygen by adding water. Are there any oxygen? Is there any oxygen? No. So we can skip step 2. And then is there any hydrogen? No. We can also skip step 3. So we will go to step 4 directly, adding electron. And then how can we balance the charge? On the right is 0, on the left it's plus 2. So we will need to add 2 electron. So now 2 negative plus 2, it's 0. So it's done. Okay, for the rest of them, you have to do it by yourself and then take the photo to me. So remember, once again, you have to memorize. You have to memorize this column. You have to memorize this column so that you can do the half ionic equation. Otherwise, you cannot do it. So for all of these, you have to memorize it. Okay? For all of these, you have to memorize it. And then for reducing agent, you should be able to do it by yourself also. And then I will do one for you as example. Okay, this time I will do the second one or the first one. Okay, as sulfur dioxide is also a famous reducing agent, because for red wine, if the wine is placed in air for a long time, then it will be oxidized to acid. Then the wine will taste sour. So to prevent the oxidation of the wine, we will add the oxidizing agent sulfur dioxide into the wine. For the bottle of red wine, we don't just add air. We add sulfur dioxide so that the wine will not be oxidized to acid easily. So sulfur dioxide is a very famous reducing agent. Okay, it can prevent oxidation because it will react with oxidizing agent first to protect the wine. Okay, so go back to the half ionic equation. Sulfur dioxide will be oxidized to sulfate ion. Okay, so first of all, balance the number of the element. Only one sulfur, so we can skip it. Step 2, balance the number of oxygen. 2 oxygen and here 4 oxygen. So that on the left hand side we need 2 more water to balance the number of oxygen. We can only add water and hydrogen ion. Okay, and then step 3, we add hydrogen ion. We should add 4 hydrogen ion on the right. And then the last step, we add electron. On the right hand side, the charge is 0. And on the left hand side, -2 plus 4. Here, -2, and then here plus 4 equals to +2. So we need to add 2 electrons on the right. So that +2 minus 2, it will be 0, and which is equals to the left hand side. So here, loses electron. That's why the electron will always on the right. Always on the right hand side of the half ionic equation. So your turn is complete the rest of them 2 to 5 and then take the picture and then send it to me. Lastly and most importantly, sometimes you will always be confused about which ion to write, which ion will be involved in the reaction. For example, when you see some question, they say iron 3 sulfate is added. Iron 3 sulfate is added. Then you may confuse whether iron 3 ion will react or sulfate ion will react or sulfate ion will react. The answer is iron 3 will react instead of sulfate ion, because you can see on this page, did it say that a sulfate ion has oxidizing property? No, it's sulfuric acid, not sulfate salts. So when you see the question say iron 3 sulfate instead of sulfate ion, instead of sulfate ion, iron 3 will be the oxidizing agent. Then we'll write the equation of iron 3 for the reaction. And also, if the question say sodium sulfate, sodium sulfide, then which one is the reducing agent? Which one will be really involved in the reaction? Is sodium the common oxidizing agent or reducing agent in these two tables? No, it's not. So we should not, sodium will not be involved in the reaction. Instead, we should write the half ionic equation for sulfide ion. Sulfide will be involved in the reaction. Sulfide will react. Another example, iron 2 sulfate. Iron 2 sulfate is sulfate ion and a common oxidizing agent or common reducing agent. You check this table, sulfate ion is not here. It's not the same as concentrated sulfuric acid. It's not the same. This one is acid. Okay, so it's not the same as sulfate ion. So not sulfate ion will be involved in the reaction. It's not sulfate ion. So instead, iron 2 will be the reducing agent which is involved in the reaction. Okay, so you have to be able to identify whether this ion will react or another ion react. So you have to be very familiar with the reducing agent and oxidizing agent. So that's all. Don't forget to submit your work to me.